Hey everybody, and welcome to your Chapter 1 Aplia homework. The problems I do here may not look exactly like the problems that you see. The numbers may change, but the problems themselves will be the same, so the process for solving them will be the same as what you see here in this little video. I wanted to make a quick note on grading. The grading option is set for do no harm. That means your highest score for each attempt and each question will be used for the final grade that goes into the class. You have 3 attempts on each question. What that means is that you can do the first question, and if you happen to get full credit for that and don't do so well in the second and third questions on your first attempt, you can go back and you don't have to do the first question again because you will get full credit for that because you got full credit on the first time. So that's what do not harm means. So the first question here is an opportunity cost. So Juanita is deciding whether or not to buy a dress she wants, as well as where to buy it. So 3 stores carry the same dress, but it's more convenient for Juanita to get to some stores than others. So for example, she can go to her local store, located 15 minutes away from where she works, and pay a marked up price of $103 for the dress. There's 2 other stores though. There's a discount mall that's the furthest away, and the dress costs the least there. So if she just goes across town, 30 minutes away, the dress comes down to $87. If she goes all the way to the discount mall in the neighboring city, the same dress exists and it only costs $64 there. Now Juanita makes $16 an hour when she's at work, and she has to take off work to go buy this dress. So she has some opportunity costs. So she does not earn her $16 an hour when she's driving around town looking for this dress. So if she goes to the local department store, for example, she drives for 15 minutes to the store, she'll drive for another 15 minutes back again, so her round trip is 30 minutes. And then it takes her half an hour to shop. So she spends an hour not at work and shopping for this dress when she goes to her local department store. On the other hand, if she goes across town, her travel time is 30 minutes each way for a round trip of an hour. And she still spends half an hour shopping for the dress. So her opportunity cost of time is going to be an hour and a half, not at work. So across town, she spends an hour and a half, not at work. So she loses $16 for the first hour and another half an hour's worth, which is $8 for the second half an hour for the shopping time. So she loses 16 plus 8 or $24 in time when she goes across town. So let me write that down for you quickly here. So if she goes for across town, her time cost is 1 hour travel plus 1 half an hour shopping. That's 1.5 times $16 an hour gets you $24. In the neighboring city, she spends, an hour driving there, and an hour driving back. So that's 2 hours plus her half an hour of shopping, so 2.5 hours. So 2.5 times 16 is $40. And I plugged that number in here. So there's your 24, your 40, and the local department store was half an hour each way, or 15 minutes each way, half an hour to shop for losing 1 hour or $16. Add in the price of a dress. So at the local department store, this dress costs her $16 plus $103 or $119 total. Cross town, it costs her $24 in opportunity cost of driving, time and shopping, plus $87 for the direct cost for the dress, that's $111. Or if she buys it in the neighboring city, it costs her $40 in time, not at work, plus it costs her $64 for the dress, or $104 total. So the cheapest place, the least expensive place for Juanita to buy this dress is in the neighboring city for $104. Now, when you do this, you'll have a different opportunity cost of time for Juanita. So sometimes the numbers are very high. In this particular case, Juanita didn't earn very much per hour. So her opportunity cost of time was quite low, so she ends up shopping in the neighboring city because that outweighs the low cost of time for Juanita, outweighs the fact that she has to drive a long ways. Now, if her salary is quite high, so if she makes $60 or $70 an hour, she's going to end up buying at the local department store because what matters is the cost of time. The cost of her time is very expensive. So as you do this, kind of pay attention to how that works and whether or not you end up buying at the neighboring city or buying at your local department store. Question 2 is just looking at the definitions of equality and efficiency. So the definitionally, when economic benefits are distributed uniformly across society, that's equality. Everybody's earning the same amount. When a society is paying attention to how much it can get from each of its scarce resources, that's efficiency. Using your resources as efficiently as possible, as carefully as you can. If the United States government lowers the income tax on the wealthiest Americans while decreasing welfare payments to the poorest Americans, there's a couple of assumptions built in here. So we're assuming that the wealthiest Americans are the ones who are also the most productive. So if we lower income taxes on people that are really productive, the message we send to those people is that they need to work more. They should work more. That's incentives, right? So lowering taxes changes the incentive to work. It tells wealthy Americans to work more. So in theory, that gets us an increase in efficiency because if they are the most productive people in our society, that's an assumption, it's not reality, but if they are the most productive people in our society, then we will get more output by telling them to work more, spend less time their time on leisure. We're decreasing welfare payments to the poorest Americans. Means that we're going to get a decrease in equality, right? So we just gave more money to the wealthiest Americans, we gave less money to the poorest Americans, decrease in equality in that case. Question number 3, a decision at the margin. So Eileen here is a hardworking college freshman. One Tuesday, she decides to work nonstop until she's answered 200 practice problems for her physics course. She starts work at 8 a.m. and uses a table to keep track of her progress throughout the day. She notices that as she gets tired, it takes her longer to solve each problem. So if you look at her table, from 8 to 9, she solved 80 problems. From 9 to 10, she didn't do as well because 140 minus 80 means that she actually only solved 60 problems. So here, she solved 80. In her second hour of work, 140 minus 80 equals 60 problems is all she did. The third hour, she's starting to get really tired or she's bored with physics. This wouldn't happen with economics, right? But with physics, this happens. 180 minus 40, she actually only solved 40 problems in that hour. And here in her fourth hour, from 11 to noon, she actually only managed to do 20 additional problems. So you can see her marginal productivity here declining. She did 80 the first hour, 60 the second hour, 40 the third hour, and only 20 the last hour. So if we go to the answers here, the marginal or additional gain from Eileen's first hour of work from 8 a.m. to 9 p.m., from 8 a.m. to 9 a.m. was, 80 problems. The marginal gain from her third hour of work from 10 a.m. to 11 a.m., that was 180 problems minus 140 problems, so that was only 40 problems there. Later, the teaching assistant in Eileen's physics course gives her some advice. Based on past experience, the teaching assistant says, working on 30 problems raises a student's exam score by the same amount as reading the textbook for 1 hour. So she needs to decide, she's got 4 hours to study, she needs to decide how many hours she should spend working on problems and how many hours should she spend reading. So she gets, when she's reading, that's equivalent to 30 problems, right? So reading raises her grade the same amount as 30 problems. Dang it. Minus 140. 40. Her fourth hour of work, 200 minus 180, 20. Now when she's studying, when she's reading, her reading is equivalent to 30 problems. So if she reads for an hour, she raises her grade by the same amount as 30 problems of doing homework would be. So reading is equivalent to 30 problems. So if she's got 4 hours here to study from 8 until noon, the question is, how much time should she spend reading and how much time should she spend working on problems? And going back to our marginal productivity here, right? The last hour, if she's working on problems, that fourth hour, 11 a.m. to noon, she only gets 20 problems. She only gets 20 problems answered. So that's not actually as effective as reading the book, right? Because reading the book is as effective as 30 problems, which is more than 20. So the fourth hour, she should definitely spend reading the book and not working on problems. The third hour, she got 40 problems done. That's better than the reading equivalency of 30. So it's the third hour she should spend working on problems. So the answer to this question then is right here. She spends 3 hours working on problems and 1 hour reading her textbook. And that's the kind of marginal analysis we're going to talk about a lot in this course. We try and make decisions on the margin, and we try to pay a lot of attention to opportunity cost. So I want to close by talking about my recommendations for how you do the homework in this class. So I recommend you start out by reading the chapter. There's a lot of other information up there in Cengage, MindTap, and Aplia. It's got too many names, sorry. So you can watch some videos, you can read the chapter, you can see what the textbook author has to say. I also have some notes on every chapter in Canvas. You can go back to Canvas and read my notes on the chapter. They're kind of the equivalent to lecture notes. Then you can do the Aplia homework and the reflection. Once you finish one chapter, all of those pieces, then go do the second chapter. Finish all those pieces on the second chapter, then go do the third chapter. Don't wait until the very last minute to try and do 3 or 4 chapters at once. I recommend that you set aside some time every day or every other day to do the homework in this class. Otherwise, you will fall way behind and find yourself in a panic situation at the end of the semester. I grade as assignments are submitted. So you get your grades back, you get my comments back. I comment on every reflection that's turned into me, so you want to read my comments on the reflection assignments. Don't wait for the due dates to submit, because I grade as assignments come in. There's no reason to wait. Go ahead and submit them. You can get my comments back, and then you can submit the next chapter, and then you get my comments back on that. So you can do it one at a time. That's a better and more effective way to manage this class. So it should be a great class. I hope that everybody appreciates this. I always enjoy teaching it. Have a great time, and give me a call if you have any questions.